Welcome to lesson 3. Just some things to go over about polynomials. We're introducing polynomials, combining like terms. Let's remember our rules for combining like terms. Terms must have the same letters to the same numbers. Same letters to the same exponents. Same letters to the same exponents. Here's some examples for you. All right, now today we're going to talk about naming polynomials. A constant. What is a constant? A constant is a polynomial such as 9 or 19. These have no variables. Any number is called a constant. It's degree 0 because anything except for 0 to the degree 0 to the exponent of 0 equals 1. So if you say 9x to the 0 power, that's the same thing as saying 9 times 1, which is just 9. So, if we don't remember, let's take a refresher. X to the first power is called linear. Linear functions make straight lines. X squared, not x2, x squared. X squared is called quadratic. They make parabolas, U-shaped figures. X cubed, not x3, x to the third power or x cubed makes shapes. We're going to talk about shapes in a little bit, but it makes a shape like that where they go to different ends. Imagine a parabola where they took one side and flipped it upside down. That's what a cubic is basically. Quartic is fourth degree. So for quartic, we got x to the fourth. Quintic is x to the fifth. Quintic is x to the fifth. Degree equals the exponent. So the constant term had an exponent of 0. Anything to the 0 power is 1. So now, terms. Monomial. If you have a number and a polynomial, that is one term. 1, 9, x, x cubed. One term, monomial. Binomial. Two terms. X plus 3, x squared plus x. These are binomials. They have two terms in them, and that's a comma separating them. And then a trinomial, you have to have x squared plus x plus 3. It could be negatives, any amount of negatives, but three terms. Three terms that you cannot add or subtract together is called a trinomial. Anything with 4 more terms is called a polynomial. These are polynomials, but they have special names to let us know how many terms we have. We looked at evaluating a polynomial before, just a reminder. So now, let's see what polynomials can look like. Okay, you look at them. Which 3 go together? So in teams, you would look at it. So let's look at all of them. So number 1 is this is written out of order. And let's talk about order now. Your highest degree must go first, and then it must descend, with this term being second, and this term being third, and this term should go last. So that's what's wrong with A. What's wrong with B? I don't know. It has a decimal coefficient. It has a decimal as a coefficient. It's written in proper order. Only thing I see is the decimal. C is the only one with a fractional exponent. This is not a polynomial because it has a fractional exponent. And D, you don't have a constant term, so there's no constant here. All of them have an x, which can be factored out. All right, so now, some polynomial function. All right, this is a card sort, which can only be done in class, so I'm not going to worry about going over this now. If you pick up your calculator and hit the y equals button, let's get ready to make some curves because it says use graphing technology to write equations for polynomial functions. All right, a first degree polynomial function who graphs intercepts. So a first degree polynomial means x is to the first power and then intercepts the vertical axis at 8, x plus 8. So y1 should be x plus 8. Hit the graph button. Look at the graph. You don't have to hit second because we're going to look at the graphs today. We're not worried about the table of values right now. A second degree polynomial, number 2, whose only has positive y values. So you're going to have second degree x squared plus 1, whatever. You could put x squared plus x. You could have put all kinds of stuff in there. But remember, with polynomials, when graphing a calculator, we're only looking at single variable polynomials. We're not going to have x squared times y. It's only going to be y equals some x to some power. A second degree polynomial. All right, so let's look at the third one. A second degree polynomial. So we're going to write x squared minus 9 on here because that contains the point 0, negative 9. Make sure after you put all these in, you hit graph. You could put them all in at the same time and hit graph, but I'm not doing the right colors. That will put them on. A third degree. Third degree means x is to the third power, whose crosses the horizontal axis more than once. So you want like x cubed plus x squared minus 3x, something like that. And a fourth degree or higher polynomial whose functions never crosses the horizontal axis. So you're going to have x to the fourth. It doesn't say how many terms you want, plus 4. Okay, so for the Are You Ready for More? This is stuff that can only be done in class. We don't have the cards, so we can't see the activity. Okay, so let's come to our lesson summary. All right, the word we're going to highlight today is degree. Degree is the highest exponent or variable. So you can read the words there, and I want to talk about a couple of things. We're going to also highlight relative maximum is higher or lower than the points around them. Relative minimum is lower than the points around them. So we're going to see this when we get to the practice problem. So what I want to say about these graphs. When x is to the first power, this is called linear. Mathematicians are lazy. They don't like writing 1, so they'll just write y equals x. Or in this terms, negative x because it's negative. Okay, this is an x cubed to the third power. How do I know? One end is here. One end is in a different place. So this is x odd. I'm sorry. We don't know if it's x to the third or x to the fifth or x to the seventh. This is x odd. Any x odd to an odd power ends in different places except for x to the first power. X to the first power is a straight line. Any x 3, 5, 7, 9, 11, they end in different places and they have a little hump in the middle. This is any x even. X squared, x to the fourth, x to the sixth. We're going to learn which one this is just by identifying how many times it touches the x. But x even, the ends of them both go to the same place. X squared, x to the fourth, x to the sixth, x to the eighth, x to the 10th power. They all go to the same place. Thank you for watching this video. I will see you in class.